Hello everybody. Hopefully you are at home relaxing, safe out of the wind and stuff, and enjoying some time off. As promised, I'm going to work out the quiz review for you guys, and I will post it on YouTube so you can review it. Remember, your quiz is going to be on Tuesday. We're going to return to school on Friday and learn section 1.6, and then from the long weekend you guys are going to have your quiz over just section 1.5. So here we go. Number one, as this is set up, you can see that you have a binomial squared. It's all by itself, and it's set equal to a number. So the most efficient thing to do would be for us to take the square root of both sides. So I have negative 2x plus 1 equals plus or minus, and I'm going to go ahead and break up negative 63 to negative 1 times 9 times 7. And then before I move anything to the other side, before I subtract and divide, I'm going to go ahead and simplify, break down my radicals. So I'm going to take out my negative 1, square root of negative 1 is I, and my 3, excuse me. So I have negative 2x plus 1 equals plus or minus 3i square roots of 7. And now I'm going to isolate my x. So I'm going to subtract 1 from both sides. So I have negative 2x equals negative 1 plus or minus 3i square root of 7. And then I'm going to divide everything by negative 2. So I have x equals negative 1 plus or minus 3i square roots of 7 over negative 2. All right, let's look at number 2. Okay, our next problem we come to, it says to solve. So the first thing I notice about this one, it's a quadratic. I have everything set equal to 0 on one side. I see that there's a GCF, so I'm going to go ahead and divide out my GCF of 3. So I have 3 on the outside here. I'm left with x squared plus 2x plus 5, and that equals 0. So from this point, we can say, okay, well, does this factor? We always want to try to solve by factoring. This one actually does not factor, which none of the ones in the quiz will, because you're going to have complex solutions. So you have two options here. You can either use the quadratic formula, or you can complete the square. Since my b term here is an even number, I'm going to go ahead and just complete the square. So I factored out the 3. I no longer have to worry about it, because 3 equals 0 is never a true statement, so we're good. So to complete the square, I have x squared plus 2x plus my square. I'm going to move positive 5 over. This becomes negative 5 plus my square. So I'm going to take my b term, which is 2, and divide it by 2, and I get 1. So my binomial on this side is going to be x plus 1, because it's a positive 1, equals, and what's going to go in each box? I'm going to square 1, so 1 and 1, so I have negative 4. So at this point, guys, we can go ahead and take the square root. So I have x plus 1 equals plus or minus. Remember, this is negative 1 times 4. So the square root of 4 is 2, and the square root of negative 1 is I. So it's plus or minus 2i. Very important that we have that. And then our last step is to just subtract 1 from both sides. So my answer would be x equals negative 1 plus or minus 2i. Now, you would have gotten the same answer if you used the quadratic formula. You just would have had to simplify at the end, so just make sure. All right, number 3 says to solve. So in this case, we can complete the square, or we can use the quadratic formula. This isn't going to factor. I'm going to go ahead and use the quadratic formula since my b term is not even. So I have a is equal to 1, b is equal to 5, and c is equal to 9. So x equals negative b, so negative 5, plus or minus the square root of 5 squared minus 4 times 1 times 9, all over 2 times 1. And as we simplify along here, we have negative 5 plus or minus, well, 5 squared is 25, minus 4 times 1 times 9 is 36, all over 2. Keep simplifying. We have negative 5 plus or minus 25 minus 36 is going to give me negative 11. You guys notice, look, there's a negative underneath. What do we need to remember about that? The square root of negative 1 is I. So when I look at negative 11, this is really negative 1 times 11. There's no perfect squares hidden in 11, but I can factor out that I. So I have negative 5 plus or minus I square root of 11 over 2. All right. right, we're going to come to number 4. You notice with number 4, guys, we don't have a b term. My a term is 3. That number in front of x squared is 3. There is no b term, so my value would be 0, and my constant, or my c, is 16. You can use the quadratic formula here, but I would not. Excuse me. I would just go ahead and say, you know what, let me just isolate x squared. I have to isolate x squared first before I take the square root. So I'm going to subtract 16 from both sides. I get 3x squared equals negative 16. Then I'm going to divide by 3. So I have x squared equals negative 16 over 3. Now that I have x squared by itself, I can go ahead and take the square root of both sides. So let's take the square root. I have x equals plus or minus. Remember, this is the square root of negative 16, so negative 1 times 16 over the square root of 3. So this would become 4i, and then I have the square root of 3 in my denominator. But guys, we've talked about this literally since like the second day of school. Cannot have a radical in your denominator, so we need to rationalize. We're going to multiply the top and the bottom by the square root of 3. So x equals plus or minus 4i square root of 3 over 3. All right, moving along to number 5. Again, we're solving. So I have a quadratic. I have an x squared, I have an x, and I have a constant. This is not going to factor. There's no GCF. My a term is not 1, and my b term is not even, so I'm just going to go ahead and use the quadratic formula. So a equals 3, b equals 5, and c equals 7. So x equals negative b, negative 5, plus or minus the square root of 5 squared, minus 4 times 3 times 7, all over 2 times 3. So as we simplify, negative 5 plus or minus 5 squared is 25, minus 4 times 3 times 7 is going to give me 84. 84 divided by 6. So now we're going to keep simplifying. I have negative 5 plus or minus the square root of 25 minus 84, which is negative 59, all over 6. And I have to remember that 59 is negative 1 times 59. There's no perfect squares hidden in 59 that we're missing or anything like that. So I'm just going to take that I out. And my final answer would be x equals negative 5 plus or minus I square root of 59 over 6. And just leave it just like that. All right, guys, in number 6, it says to simplify. It's not going to tell you what to do on the quiz. It's not going to say multiply, add. You guys have to know that. When you have two parentheses that are just stuck together right next to each other, that means to multiply. And remember, there's no I squareds in our answer. I squared is equal to negative 1. So when we FOIL this, 3 times 4 is 12. 3 times negative 6 is negative 18i. 2i times 4 is plus 8i. And 2i times negative 6i is negative 12i squared. I've told you guys, every time you see an I squared, cross it off and change the sign in front. And then we combine real with real. 12 plus 12 is 24, and imaginary with imaginary. Negative 18i plus 8i is minus 10i. And there is your simplified answer. Okay, you're going to have a question or two like this on your quiz where you have to simplify I to a certain power. So I have a positive exponent, so I know I'm going to keep I in the numerator. And then we talked about rewriting your i's in terms of I squared. So I'm going to write this as I to the 206 power times I to the first power. So now to write this in terms of I squared, I have I squared. I'm going to divide this exponent by 2. So 2 goes into 106. Sorry, 2 goes into 206. 103 times I, right? 2 times 103 is 206. So I replace my I squared with negative 1 to the 103rd power times I. So negative 1 to the 103rd power, it's an odd power, so it's going to be negative 1 times I. So my answer is negative I. Okay, come to this problem. Again, it says simplified. It's two binomials that are stuck next to each other. That means we're going to multiply. So 3 times 3 is 9. 3 times negative square root of negative 5 is minus 3 square root negative 5. Positive negative root 5 times 3 is plus 3 square root of negative root 5. And then a negative times a positive is a minus. So I have negative 5. So what happens here? My insides, these are opposites of each other, so they cancel. I have minus a negative, which gives me a plus. So 9 plus 5 gives me 14. Okay, again, we have another simplifier with these i's. So I am going to break this down into I to the 32nd power times I to the first. I'm now going to write this in terms of I squared. So I can take I squared. If I divide 32 by 2, I get 16 times I. So I have negative 1 to the 16th power times I. So negative 1 to the 16th power is going to be positive 1 times I. So I have 1 over I. But guys, just like you can't have a radical in the denominator, you are not allowed to have an I in the denominator. So we need to rationalize. I'm going to multiply the top and the bottom by I. So this becomes I over I squared. Well, what does I squared equal? Negative 1. So my answer is negative I. Okay, another simplify. Guys, you notice here you have a negative exponent. How do we make a negative exponent positive? You got to move it. If it's in the denominator, you move it to the numerator. If it's in the numerator, you move it to the denominator. So the first thing I'm going to do is move this up here. So I have I to the positive 25th power. Now I'm going to rewrite it. So I have I to the 24th times I to the first. I'm going to write my I to the 24th in terms of I squared. So I squared, and divide that by 2. So to the 12th power times I. Negative 1 is I squared times I. So negative 1 to the 12th power is positive 1. So your answer is just simply I. So now we come to a problem like number 11. On your quiz, it may say rationalize, it may say evaluate, it may say simplify, but it's not going to tell you what to do. You need to look at this and say, oh, wait a second, there's an I in the denominator and I can't have that. So how do we rationalize? You can multiply the top and the bottom by 3i if you wanted to. You would just have to do a little more simplifying at the end, but I'm going to multiply the top and the bottom by just the I itself. You don't have to use the number in front of it. So this becomes 4i over 3i squared. As soon as you see I squared, guys, you cross it off and you change the sign in front. So when we rationalize this, this just becomes negative 4i over 3. Again, on your quiz, it may say simplify, it may say rationalize, it may say evaluate, but again, we have an issue here. We have an I in the denominator. So how do we get rid of i's in the denominator when you have more than one term? This minus sign is keeping the 4 and the negative 3i, the 3i together. So we have to multiply by the conjugate, the complex conjugate. Complex conjugate of 4 minus 3i would be 4 plus 3i. What you do to the bottom, ladies and gents, you have to do to the top. So I'm going to go ahead, I like to multiply my denominator first just to make sure my i's cancel. So 4 times 4 is 16. 4 times 3i is plus 12i. Negative 3i and 4 is minus 12i. And negative 3i and positive 3i is minus 9i squared. As soon as I see that I squared, I cross it off, change the sign in front. I notice my positive and negative 12i cancel. So I have 16 plus 9, which gives me 25. And then in my numerator, 3 times 4 is 12, and then 3 times 3i is plus 9i. So I have 12 plus 9i. And we like to see if we can simplify anything between the numerator and the denominator. In this case, we cannot, so you can just leave it just like that. If you wanted to factor it, okay, another one of those rationalizing, simplify, evaluate, something like that. So watch what the directions say. Don't misread this. You have to get the I out of the denominator. What is the problem here where some of you will run into? You'll forget to multiply by the complex conjugate. What is the complex conjugate of the denominator? That would be 4 plus 5i. So what you do to the bottom, you do to the top. So make sure, guys, I would multiply my denominators first to make sure that my i's cancel. So 4 times 4 is 16. 4 times 5i is plus 20i. Negative 5i and 4 is minus 20i. And negative 5i and 5i is minus 25i squared. As soon as you see that I squared, you cross that off and you change that sign in front. Your negative and 16 plus 25 is going to give me 41. And then my numerator, I'm going to go ahead and FOIL. 4 times 4 is 16. 4 times 5i is plus 20i. 5i times 4 is plus 20i. And 5i and 5i is plus 25i squared. You see that I squared, you cross it off, you change that sign in front. So we have 16 minus 25, which gives me negative 9, and then 20i plus 20i gives me plus 40i. And you can leave it just like that. If you would like to separate it, negative 9 over 41, sorry, plus 40i over 41, you can. Either way is fine. WebAssign wants it this way, but we're good right here. Okay, and this one, it's telling you to multiply. Again, on the quiz, it'll probably just say simplify or evaluate or something. But guys, before you can multiply these two together, this is not a foiling problem where you have two binomials. This is one term here, and this is one term here. What we need to make sure that we do is simplify the radicals, take those i's out before we go ahead and multiply. So I'm going to rewrite this as 3 times negative 1 times 21. And then over here, we have 4 times, and I have negative 1 times 14. So the first thing we need to do is go ahead and get that negative 1 out of there. So I have i's. So this becomes 3i square roots of 21 times 4i square roots of 14. So now you can multiply the outsides. 3i plus 4i is 12i squared. As soon as I see that I squared, I'm going to cross it off and make this a negative 12. And then a house times a house is just a bigger house. So it's 21 times 14. You guys can go ahead and multiply 21 times 14 and then figure out factors and all that stuff. Or we can go ahead and split it up underneath here. So I have 3 times 7, and then 14 is 7 times 2. So I see right here, oh, wait a second, I have a pair of 7s. This is a square, that's a perfect square right there, because 7 times 7 is 49. So I can bring that 7 out, and I can multiply on the outside. So I have negative 84 times the square root of 6. Exact same problem here. We want to go ahead and simplify, take out that negative underneath the radical before you go ahead and multiply. So I have negative 1 times, we'll say 3 times 5. And then I have negative 1 times 9 times 3. So what can I take out in my first parenthesis? Just this I. So I have I square root of 3 times 5. You could leave it as 15 if you want. Here, what can I take out? I can take out an I and a 3. So I have 3i with radical 3 left underneath. So now I can multiply the stuff on the outsides. I have 3i squared. As soon as I see I squared, I cross it off and change the sign in front. And then my house times a house is a bigger house. I have 3 times 3 times 5. And I notice, oh, I have a pair of 3's that can come out. 3 times 3 is 9. The square root of 9 is 3. So I'm going to multiply it right here. So negative 3 times 3 is negative 9. And I have the square root of 5 left over. Okay, guys. Hopefully here you say, oh, I'm going to divide because I have a radical on top of a radical. First thing we want to do before we do any division or anything like that is to take out those i's. So I'm going to rewrite this as negative 1 times 600 divided by negative 1 times 50. Now some of you are going to want to go ahead and break down 650 into 6 and 100, 25 and 2. You can do that, absolutely. I'm just going to wait a second here. I'm going to go ahead and take my i's out. So if I have an I on the top and an I on the bottom, they cancel. And then I know that this is the same thing as 600 divided by 50, all under one radical. You can separate it or you can put it together. So I'm just going to go ahead and divide by 10 right here. So now I have 60 divided by 5, which is 5 goes into 5 once, 5 goes into 60 12 times. So I have the square root of 12. And we would never leave our answer like that. 12 is the same as 4 times 3. So I'm going to take out my square root of 4 is 2. So my answer here is 2 square roots of 3. Okay, again, we're multiplying it. It's not going to say to multiply in the quiz, but you notice there's no plus or minus in between your parentheses here. You just stuck together. So when we multiply, outside with outside, inside with inside. So 3i root 2 times 3i root 2. Well, 3i times 3i is 9i squared. And the square root of 2 times the square root of 2 is square root of 4, which is 2. As soon as I see that I squared, I'm going to cross it off and change the sign in front. So then I have 3i square root of 2 times negative 5. That's going to give me negative 15i square root of 2. Then I have 5 times 3i root 2, so it's plus 15I square root of 2. And then I have 5 times negative 5 is negative 25. You guys notice here, the negative 15I root 2 and the positive 15I root 2 cancel. Negative 9 times 2 is negative 18 minus 25. Simplifies to negative 43. Okay, again, we're going to simplify. I have a negative underneath the radical, so I need to deal with that first. Before I do anything, I'm going to say this is 9 times 7, and this is negative 1 times 7 times 2. So what can I take out here? I can take this out, my negative 1. This is going to become I. I can take out the square root of 9 is 3, and I know I have a 7 on the top and 7 on the bottom. So I am left with 3 over I square root of 2. Now here's a double whammy, guys. We have two things wrong here. We have the square root of 2 and we have an I, so we need to rationalize and multiply by both. So I'm going to multiply the top by I root 2 and the bottom by I square root of 2. So when we do that, in the numerator, I have 3I square root of 2. And then in my denominator, I times I is I squared. The square root of 2 times the square root of 2 is the whole number 2. So I see here, I have an I squared. I cross it off, and I put a negative sign. So then my answer is negative 3I square root of 2 over 2. So they just fell off of our tree, and my daughters are excited. All right, now on number 19, I say it just says simplify. I notice I have a negative exponent. So how do we make a negative exponent positive? We move it. In this case, it's in the numerator. I'm going to move it to the denominator. So 1 over I to the 35th power. Now we're going to split up 35 to I to the 34th times I to the first. You want to go to an even exponent, so then you can write your I in terms of negative, or I squared, negative 1. So now I'm going to write this in terms of I squared. So I have I squared, take 34 and divide it by 2 to the 17th power times I to the first power. So I have negative 1 to the 17th power times I. Well, any number that's negative and you raise it to an odd power is going to stay negative. So it's negative 1. So I am left here with 1 over negative I. Again, guys, cannot have i's in our denominator. So what are we going to do? We're going to rationalize. Just multiply the top and bottom by I. It doesn't have to be negative I. So you're left with I over negative I squared. So think about this. Watch, watch, watch. This is negative, and then I squared is negative 1. So negative, negative gives me a positive. So my simplified answer here is just I. And then the last question on this review is we're going to take the square root of negative 52 and square it. So guys, when you square a square root, this is just going to become negative 52. But what I want you to see, what you have here is the square root of negative 52 times the square root of negative 52, right? So this is the square root of negative 1 times 52 times the square root of negative 1 times 52. So if we take out the I here and I here, you have I square root of 52 times I square root of 52. So you multiply the outsides. I times I is I squared, and then the square root of 52 times the square root of 52 is just 52. And guys, remember I squared is negative 1. So negative 1 times 52 is negative 52. That's how that works. I'm going to record the class kick probably tomorrow, and I'll post it. So make sure you guys are looking over this video. Come to class on Friday and ask questions. Come to see in the morning if you have any, something like that. I am going to go on to lesson 1.6 on Friday, but I will be able to answer a couple questions in class if you have any in preparations for our quiz. Stay safe.